guys, and welcome. Today I wanted to talk about a really interesting topic, which is probably not as popular as space exploration or fully automated vehicles, but it has all of the potential to change our daily lives forever. And those are brain-computer interfaces. They are used by connecting us to a specific network or to internet in general through using a specific device that will transmit our thoughts to all of our devices or through internet or any other connection. By doing that, we can achieve all of the connections with the multitude of devices that we will have and that we have. And why I'm saying we will have, because we have a lot of ideas and concepts and investments in smart homes, smart cities, smart hospitals, etc. And as the time progresses, we will see more of automated devices in our daily life, and using brain-computer interfaces is probably the way to go to interact with them. And if we couple it with augmented reality and virtual reality, we will have not only transformation of our workspace, but we'll also have a transformation of our entertainment, because we have humongous impact on gaming industry by replacing all the controls with our thoughts pretty much. And it's a really big and interesting topic, and I will discuss it in full in the following video.
Let us explore what advancements had there been in brain-computer interfaces and see at what levels the technology currently is, starting with the field of medicine. A team of researchers from Carnegie Mellon University, in collaboration with University of Minnesota, has achieved a breakthrough in the field of non-invasive robotic device control. Using a non-invasive brain-computer interface, or BCI, they have managed to develop the first ever successful mind-controlled robotic arm, exhibiting the ability to continuously track and follow a computer cursor. The main application of this would be allowing the paralyzed patients to control their robotic limbs with their own thoughts. And that's only at a glance. This can be transmitted to other robotic devices as well, going as far as allowing the engineers and scientists to control more sophisticated robotic arms for the practical engineering purposes or scientific experiments. The research team has demonstrated enhanced brain-computer interface learning by 60% improvement over the previous speeds for the typical tasks, and 500% improvement in continuous tracking. Facebook has recently acquired CTRL Labs, a brain-computer interface startup, for over $1 billion. This company specializes in wrist-worn hardware that picks up nerve signals from the skin using electromyography, EMG, translating them into movement signals that can be used to control digital devices. Gaming companies also have a significant interest in BCIs, and as mentioned above, they have a huge potential when coupled with VR technology, simply by replacing the game controls, allowing the user to completely immerse themselves into virtual worlds. A more interesting application of BCIs is the ability to connect the brain to the internet in real time. This can be achieved by turning the brainwaves into a node in the Internet of Things, IoT, on the World Wide Web. This was illustrated in the experiment by Adam Pantanovitz, a lecturer in the Witt School of Electrical and Information Engineering, and it's called BrainTernet. He states that BrainTernet is a new frontier in brain-computer interface systems. There is a lack of easily understood data about how a human brain works and processes information, and BrainTernet seeks to simplify a person's understanding of their own brain and the brains of others. It does this through continuous monitoring of brain activity as well as enabling some interactivity. It works by converting electroencephalogram EEG signals, brainwaves, into an open source brain live stream. This is done through a powered mobile internet accessibility emotive EEG device. It transmits the EEG signals to a Raspberry Pi, a credit card-sized small computer that live streams the signals to an application programming interface, code that allows software programs to communicate, and displays data on a website that acts as a portal. They aim to enable interactivity between the user and their brain so that the user can both provide a stimulus and see the response. On top of that, it can be further improved to classify recordings through a smartphone app that will provide data for a machine learning algorithm, with the potential to transfer the data back and forth from the brain and to the brain. Overall, this shows that there is a significant perspective for the BCIs, especially if they're created on a smaller, portable scale, and obviously, if they won't require any kind of surgery, um, obviously the non-invasive ways. And it can be used as an ultimate security device, allowing access to everything from PCs to cars. It also can be used to directly interact with a multitude of devices that one can possess. Just imagine interacting with your PC at home while you're driving your car and getting required information from it directly, or accessing the cloud networks at your workplace while sitting at home. The whole idea of it would be to seamlessly connect us to internet and through it to all of our devices, or through Bluetooth or Wi-Fi, where we would be able to function as a node in a greater network. And coupled with advancements in VR, and hopefully with advancements in augmented reality, we would have an interface to go along with it, allowing us to interact as if we were using a PC anytime and in any place. The key part in here would be developing a portable device with enough sensitivity to capture the brainwaves, something that can be used by an average consumer without requiring complex setup. And of course, the smaller it will become, the better. The above-mentioned concept of the Internet of Things is very interesting in itself. It refers to the countless devices around the world that are all connected to the Internet. These devices can effectively communicate between each other without even requiring human presence. The point of BCIs here would be to establish a direct communication pathway between human brain and external device, thus eliminating the need for a typical information delivery method. Recent trends in BCI research have witnessed the translation of human thinking capabilities into physical actions, such as mind-controlled wheelchairs and IoT-enabled appliances. BCI should become a major aiding technology in human-device interaction. However, current cognitive recognition systems can achieve about 70 to 80% accuracy, which is not exactly sufficient to design a practical system. In the paper titled Internet of Things Meets Brain-Computer Interface, a unified deep learning framework for enabling human-sync cognitive interactivity, the team of scientists proposes a unified deep learning framework for enabling human-sync cognitive interactivity, with their framework measuring the user's brain activity, such as EEG, fNIRS, and MEG, through a specific brain signal collection equipment. The raw brain signals are then forwarded to the cloud server via the internet. The cloud server uses a person-dependent pre-trained deep learning model for analyzing the raw signals. The analysis results interpreted signals could be used for actuating functions in a wide range of IoT applications, such as smart cities with transportation controls, schedules, and everything else. Smart hospital, like emergency calls, anomaly mentoring, smart homes, appliances control, assistive robot control. Their framework aims to interpret the subject's intent and decode it into corresponding commands, which are discernible for the IoT devices. So basically, translating our brain signals into something that devices will recognize and that would act straight away on the commands that we're giving them. In the papers, they propose a weighted average spatial long short-term memory. Uh, WAS LSTM to exploit the latent correlation between signal dimensions. This proposed framework is capable of modeling high-level, robust, and salient feature representations hidden in the raw human brain signal, and capturing complex relationships that exist within the data. In their experiments, they've used an emotive Epoch Plus headset, which collects EEG signals and sends the data through a Bluetooth connection. The raw EEG signals are then transported to the server through a TCP connection. The device in itself is portable and demonstrates the most ergonomic design from anything that can be found on the market right now. Not to mention that it is available for purchase by any consumer as well. So on this example, we can see a piece of technology that all of us can buy and use, which is quite a milestone for it. Even though later iterations of such devices will definitely get smaller and more portable. A well-designed working product is a great example of the current state of technology, but it will definitely improve. And there is some additional horizons that this can be applied at. I mean, if we are going as far as smart cities, smart hospitals, we might get even smart factories, where you put on your headset, and or basically an engineer puts on his headset, and he uses his thoughts to operate all of the devices in the factory. Or we're using all of our thoughts to operate all of the devices in a hospital. Like, for example, a surgeon might use it to conduct a surgery, which is, I mean, it's a bit far-fetched because surgical devices should be extremely precise, but it is a possibility. And in smart cities as well, particularly if the technology gets widespread, with all of the devices surrounding us in a smart city, like from cars to traffic to everything, we'll just be able to influence everything with the power of our thoughts, without requiring to push buttons and everything. And the more the technology goes, the more reliable it should become. And we'll have like social networks that are connected to our brain, and we wouldn't even need to talk to each other because we could communicate with our thoughts. And it will definitely revolutionize everything. And it has the potential to replace the smartphones, most certainly. And as I mentioned, if it's coupled with smart glasses or something resembling VR, but I would say smart glasses with augmented reality would be a better way to go along with it, because we'll be able to use it seamlessly in our daily lives. Like, for instance, you're walking from your groceries to your home, or are you going from your work to your lunch place, and you can answer text messages by just thinking about it. And you can even send voice messages just without opening your mouth. Like, you can sit in a meeting and be sending voice messages to other people without uttering even a sound. And I think this communication mode will become quite prevalent if the technology takes hold. And on top of all that, you can, I mean, for instance, send your it might sound a bit futuristic, but hold on with me. You have an automated car, right? And you're sending it to groceries by the power of your thoughts. So basically, you send your car from home to the grocery store, and your groceries get shipped to you by automated robots, and it's all packed in your trunk. And by the time you get back home, your car has already went to groceries, bought all your groceries, came back home, and it's all loaded off, I mean, by the robots that have assisted putting it out of your trunk, for instance. It's super futuristic, but basically you would be, if we will have the smart cars, which are fully automated, we'll be able to send them on specific errands, like go pick up the kids or go into groceries and everything. And we'll be able to use just the power of our thoughts. We'll just, by thinking about the car going there and there, we'll be able to control it entirely, which is, I mean, quite convenient. So yeah, that's it about the technology. I think it has a lot of perspectives, and it has a lot of ways it can develop, and it's definitely something to look forward to, even though it's not as popular in scientific media as some other topics like SpaceX and space exploration, but it's something really interesting. Thank you for watching the video. I really hope that you enjoyed it. If so, please give it a like and subscribe to the channel for more videos like this. You can read my entire article on the subject by following a link below.